Hey, what's going on, guys? So, Mr. Flores here, and this is going to be the last video that deals with matrices, and we're going to be talking about inverse matrices, or inverse matrices. So, before we get into it, let's just talk about inverses and stuff in general. So, if we have the equation 3x equals 9, alright, we want to get x by itself. So, the 3 and the x are being multiplied, okay? So, what we want to do to get the 3x to become a 1x is we just divide both sides by 3. So it's going to get x equals 3 because, well, 9 divided by 3 is 3 and x equals 3. Right? So that, in a nutshell, is the idea of an inverse. You kind of want to take something and get it by itself. Or if we talk about more math terminology, and the inverse property of multiplication basically says that if we have 8 over 1, okay, we need to find something we can multiply it by, so our answer is just 1, or the identity of multiplication, which is 1. So what can we multiply 8 over 1 by to get 1? Well, we're just going to multiply by the reciprocal of 1 over 8. Okay. Another way we can write this is you could just say 8 times 8 to the negative 1 equals 1. Because if we remember our rules of exponents, 8 to the negative 1 is the same thing as 1 over 8. Okay. So basically this says that a times a over negative 1, a to the negative 1 is equal to the identity, okay? This is just for multiplication, but this is kind of what we're going to deal with when we're talking about matrices, okay? Because matrices, we can add them, we can subtract them, we can multiply them, but we can't really divide them, okay? And kind of the idea of dividing matrices is that we can't divide it, but we can multiply by inverses, and it does the same thing as division. It's kind of tricky, so just take my word for it, okay? And in multiplication, the identity is 1, okay? Because if you're multiplying two numbers and you want the identity property, you get them equal to 1. So an identity matrix is really just a matrix where its diagonal is a bunch of 1s. Everything else is a 0. So that's a 2 by 2 identity matrix. You can only have square ones. This is a 3 by 3. Okay, there's a 1 in the down diagonal, and then everything else is zeros. When we're talking about inverses and identities, we're only talking about square matrices, okay? So if you're given a matrix and it's not square, you actually cannot find the inverse of it, okay? So basically what we want to do here is we want to, of course, in math, we always find shortcuts. Now, the way we can find inverses gets very, very tedious, okay? And we're only going to do 2 by 2 matrices by hand. 3 by 3s and higher, I can show you on the calculator. But with a 2 by 2, okay, it just follows a basic formula, just like determinants and Kramer's rule. It just follows a formula. So say we have matrix A, where it's A, B, C, and D. Okay, matrix A inverse is equal to 1 over the determinant of A times D negative B negative C A. Okay, and again, this was derived from a formula for finding determinants of matrices and everything, and just take my word for it. If you have a matrix A that is A, B, C, D, the inverse of A is 1 over the determinant of A times D negative B negative CA. So in reality, you're just switching the down diagonals, making the up diagonals both negative, okay? And then you're going to multiply it by 1 over the determinant of that matrix. So basically, just like in everything when we're talking about determinants, we're talking about everything in matrices, whether we add them, subtract them, or multiply them, there are times when you can't get no solution, okay? Now, of course, if we look at this equation, we need the determinant of A never to equal a certain number, because in reality, it's 1 divided by the determinant of A. And if you remember from our past math classes, you can never divide by 0. So the only way that you cannot, that a 2 by 2 square matrix does not have an inverse is if its determinant is equal to 0, okay? So the first thing we're going to do is we're just going to check and see if it's possible to get the inverses of certain matrices. All right, so we have two matrices here. We have matrix A, matrix B. I want us just to see if matrix A has an inverse, okay? The way you check that is you just take the determinant of A, and as long as the determinant of A doesn't equal 0, it has an inverse. If the determinant of matrix A does equal 0, so this means has inverse. If the determinant of A does equal 0, there's no inverse, okay? Because to find the inverse, you take 1 over the determinant and multiply it by the this messed up version of the matrix. But you can't divide anything by 0, so therefore if the determinant equals 0, you can't have an inverse. Hopefully you understand that. But real quick, I'll do 2 quick examples. So what I want to do is I'm going to take the determinant of A. Okay, it's going to be equal to negative 2 times 1 minus negative 6 times 1, which is going to simplify to negative 2 plus 6, which is equal to a positive 4. All right. Therefore, the determinant of A is positive 4. That's not 0, so matrix A has an inverse. Okay. Now let's go to matrix B. So the determinant of matrix B is equal to down diagonal. So 3 times negative 4 minus 12 times negative 1. So 3 times negative 4 is negative 12 minus a negative 12. This becomes plus. Negative 12 plus 12 equals 0. Therefore, B doesn't have inverse. Have an inverse. Because its determinant is equal to 0. And that's not allowed because you can't divide by 0. And matrix A does have an inverse. Oops, that's not English. Does have an inverse. Okay, so that's the quick way off the bat. You can check to see if you can actually find the inverse of a matrix. Oops, sorry about that. In 1 second, we are going to actually find the inverse of a matrix. All right, guys. So what I have here is I have a matrix in matrix B that is 4, 1, 3, 1, and we want to first check and see if we can find the inverse of B. If we can find the inverse, we're actually going to go ahead and find it. So the first thing we have to do is first take the determinant of B, because if the determinant is equal to 0, there's no inverse. But if we look here, it's going to be 4 times 1 is going to be 4 minus 3 times 1 is 3, which is equal to 1. Okay, so right off the bat, we're lucky because the determinant of B is equal to just a 1. All right, so now, in order to find B inverse, what we're going to do is we're going to take 1 over, well, in this case, it's just 1, so it's actually nice and simple. And we're just going to multiply that by, originally it was 4, 3, 1, or 4, 3, 1, 1, but in the inverse, you must flip-flop A and D, so this becomes 1, this becomes 4, and you just negate C and B. So it's equal to negative 3 and negative 1. Okay, and again, when you multiply that by 1, B inverse is just equal to 1, negative 3, and 4. All right, so that's very nice. That's pretty cool, because now the inverse of B is equal to 1, negative 3, 4. All right, now the one thing, of course, because you can always check your answers, is if we go back to the last slide in the beginning of this video, we said that if you take a matrix A, multiply it by its inverse, it's equal to the identity matrix. The identity matrix for a 2 by 2 is 1 in the diagonals going down, every other thing's a 0. So we're just going to check and see to make sure that we did our math right. All right, so if I take B, 4, 3, 1, 1, and remember, multiplication is not commutative in matrices, so you must put your matrix first, the inverse second. 1, negative 3, and 4. Okay, so when we multiply these, I'm going to go very quickly just because we all know how to do this. To get our first number up here, it's going to be row 1, column 1. So 4 times 3 is 4, plus 3 times negative 1 is a positive 1. Down here, we're going to do row 1, row 2, column 1. 1 times 1 is 1, plus 1 times negative 1 is 0. 4 times negative 3 is negative 12, plus 3 times 4, negative 12 plus positive 12 is 0. And then row 2, column 2, 1 times negative 3 is negative 3, 1 times 4 is 4, negative 3 plus 4 is just 1. So therefore, we can see that right off the bat, these actually, in fact, are the original matrix and the inverse, because when you multiply them, you get the identity matrix. All right, and that one was very nice. It was very simple, but I just want to do that quick example just so you could see what the identity matrix looks like when you multiply the original by its inverse. You get the identity. But again, you don't always have to do all this looking and checking because, well, you're brilliant. No, I'm kidding. You are brilliant. But a lot of times, this, as long as you do the process, because it is a simple process, just check to make sure your signs and everything are right. And you don't always have to check your answer. You should, but not everyone always does. All right, the last example, I'm going to find the inverse of matrix C. Matrix C is 3, 4, 1, 2. And again, before we can check and see what the inverse is, we have to see if there is a possible one. So first, you must find the determinant and hope that it does not equal 0. All right. So if we look at determinant of C, it's going to be 3 times 2, which is 6, minus 1 times 4, which is going to be 2. All right, because it's 3 times 2 is the down diagonal, subtract the up diagonal, 6 minus 4 is 2. So therefore, we know that we can have an inverse since the determinant is not equal to 0. And if you go back to our formula, we're going to take 1 over the determinant and multiply it by the switching around of some of these units. So A and D switch, so it becomes 2, 3, and B and C just become negative. All right, so when we basically just multiply 1/2 by this matrix, it becomes 1/2 times 2 is 1. Negative 1 times 1/2 is negative 1/2. Negative 4 times 1/2 becomes negative 2, and 3 times 1/2 just becomes 3/2. And there you have it. Here is the inverse of matrix C. All right. If you wanted to, you could multiply matrix C by the inverse, and you would get the identity matrix. I'm not going to do that because hopefully by now you guys know how to multiply matrices. Again, 3x3s and bigger, we would use a calculator, but this is how you find the inverse of a 2x2 matrix by hand. If you have any questions, let me know. Check out the rest of the videos, and I hope you have a good one.